Hello. In this module of Energy 101, we're going to talk about the energy conversion. We've talked about the ways that society uses energy and where we get that energy from. We talked about why society and where society uses it. We talked about where the natural forms of that energy come from, because we can't create energy out of nothing. And now we're going to talk about energy conversion that converts the energy from the natural forms that we find it, like coal and natural gas and nuclear and oil and wind and solar and hydro and all biomass and all the natural forms that we find this energy in. But it doesn't do us any good unless we can convert it from the form that we find it in this natural state to a form the society wants it. So that's where we're headed on this module. Let's break that conversion process down a little bit further. On the left here, we have the natural forms of energy that we find them in the natural state, and we have the society uses that we have them that we want to make life more comfortable, heat and work and chemical energy, cooling energy, and electricity. But now let's talk about the energy conversion process to convert those. The devices, the infrastructure, the equipment that's necessary to convert energy from one form to the other are fossil fuel power plants like coal power plants, natural gas power plants, nuclear power plants. Nuclear is not fossil, but moving down to nuclear. The auto engine converts gasoline that comes directly from oil, and the diesel engine takes diesel fuel that comes directly from oil on essentially a one-to-one energy basis and drives a car for transportation, which is in the work form. Natural gas furnace heats our homes. Air conditioning keeps our homes cool. Pump the water from the wells into our bathrooms and our kitchen, and take showers, so we don't have to haul it with buckets. The refrigeration system preserves our food, so we don't have to shop every day for fresh food. And then the light bulb converts electricity to light, which the electricity, of course, is produced from the power plants. So these are the conversion processes and the equipment. One thing that I'll note here, that we can't just change getting energy from oil, gas, or coal, for instance, to produce heat or electricity that we want in society without changing the equipment that's necessary to make the conversion. And that infrastructure is a huge investment. It's a huge economic investment. So that's one of the problems with going to renewables from coal, for instance, or nuclear, because we have to replace the infrastructure that we're currently using to convert coal or natural gas to the form of energy we want it to. A totally new conversion process requires all new equipment, and this is like trillions of dollars in order to do that on a national basis. Just one note that we need to be aware of there. But that conversion process is what we're going to focus on now. The conversion process has some natural laws that govern what can be done and what we can't do. And this isn't a science course, and I'm not a scientist and a philosopher that talk about why the laws are the way they are. They're natural laws that the way the earth is made up. Gravity pulls down, not up. We don't debate why it doesn't pull up, why it pushes down. Same way with the natural laws of energy conversion. And those natural laws are divided into two primary laws. The first law of energy conversion, many times called the first law of thermodynamics, and the second law, which we'll get to in just a minute. So in this module, we're just going to introduce these concepts. But the first law of thermodynamics, or the way nature makes us operate, is that energy is conserved, as we've already commented. We can't create nor destroy energy. Total energy cannot be created or destroyed. And so we can't just produce it from nothing. And yet, too many times our intuition tells us, well, why can't we get energy from all of the molecules bouncing around in the atmosphere, for instance? But it just doesn't allow us to do that even. But the first law of thermodynamics says we cannot produce energy, we can only convert it from one form to the other. That's a major issue. So when we talk about breakthroughs in energy technology, it's merely a breakthrough to convert energy from a new form that we can find it, like solar energy or wind energy, into a form that we want it. We haven't discovered a new form of energy. That wind energy and solar energy was always there. We merely developed the technology and the infrastructure to convert it. Trying to give you a little bit of intuition on this, the analogy that our intuition probably a little bit more consistent on is that total mass cannot be created or destroyed. You can't just annihilate mass, nor can you create mass. We can have a chemical reaction and change mass from one type of form to another, but the total mass stays the same. You can take two components and react them, but the resulting mass is going to be sum of the two that you started out with. So that's the first law of thermodynamics, which makes a little bit of intuitive sense if we think about it from similar to the mass conservation. The second law of thermodynamics is even less intuitive than the first might be. And it really says all forms of energy do not have equal value. Whereas a kilogram or a pound of mass is equal to another kilogram or pound of mass, they may not have equal value. Well, the second law of thermodynamics, or the second law of energy conversion, has a similar statement about energy. The forms of energy some have higher value than another form, and that's just the way nature has built the universe, and we can't get around it. We've known this for 150 years, and it's no new discovery. The first law of thermodynamics is 150 years old. The second law is about the same, and so we have to operate with those laws of physics. But as an example, work energy or electrical energy has a higher value than warm air or hot air energy. You may have an equal amount of energy in each, but they aren't of equal value. Again, taking an analogy from mass, is that even though a pound of gold is equal in mass to a pound of silver, they are not of equal value from many perspectives. And you can't just change 100% of a kilogram of silver into 1 kilogram of gold. It just doesn't work that way. So those are the two basic laws that control our energy conversion, from the natural forms that we want it, that we find it, to the forms that society wants it, and we'll delve into those a little deeper in the next two modules. Thank you.